Sorry I can't be with you today to show you this in person, so I'm just making a video so you'll help you understand. Once you get to this point, it's just some extra practice since this is all brand new. This sheet that you'll pick up is titled Chemical Reactions. That if you see the little green square plus a yellow square yields a red square, just the reactants together become a product which is new. Activation energy is required to get the green and yellow to become the red. Law of conservation of mass, matter can't be created or destroyed in a chemical reaction. That just means that the number of atoms you have on the reactant side must all come out as products. They may be reshuffled or recombined in a different way, but you can't get rid of an atom or make a new atom. So then it states at the bottom, turn the page over. And when you do that, it says paperclip activity, pure excitement. Done this before with mixtures and compounds. So we're just using this to help you understand matter not being created or destroyed, just maybe recombining in a different way. But this is what you're going to practice. Is called balancing an equation. Very important vocabulary. A subscript is the number to the lower right. It's kind of below the line, that's why sub means below, that tells you how many atoms of that element are there. Like H2 would be 2 hydrogen atoms. Coefficient is a number that's used in math a lot. It's what goes in front of the variable. In this case, it would go in front of the element number. Like 2H2O in this case, which means there's 2 water molecules. So in 2 water molecules, there are 4 hydrogens, because 2, the coefficient times the subscript would be 4 hydrogen, and also 2 oxygen. So it distributes, just like in a math problem, 2 oxygens. So we set up an unbalanced equation. We're using paper clips to create this. So what I've done is chosen 3 different colors. You should do the same. You should have 3 different colors of 4 stacks. So I'm going to use green for hydrogen, red for oxygen, and then on this side of the equation we're going to make water. So hydrogen says 2 hydrogen atoms linked. So just link them up. Pretty simple. Put them through there, they're linked. So there's 2 hydrogens linked together here. And on this right here is going to be 2 oxygens linked together here for the reds. So 2 oxygens linked together like that. Now on this side it says H2O. So we need 2 hydrogens and 1 oxygen linked together. Okay. There we go. 2 hydrogens, a link to 1 oxygen. Alright. Now, the first question to answer below here. Are there the same number of hydrogen atoms on the reactant side as there is on the product side? We see 2 hydrogens here. We see 2 hydrogens here. Okay? Second question. Same amount of oxygens on the reaction side or the product side. How many oxygens do we have? 1, 2. How many on this side? 1. So the problem is the oxygens are not balanced, but the hydrogens are. So using only coefficients, because we can't change the subscripts. If you change the subscripts, it's like changing the number of protons in an element. It's going to change what that compound is. The compound has to have that same subscript or it'll become something different. And you'll learn about that the more you do about chemistry. So at the bottom down here, you work with a partner to figure out how to balance this equation. So the easiest thing that I know to do is, instead of having 1 water molecule on this side over here, in order to get 2 oxygens, you're going to have 2 oxygens. And in order to have 2 oxygens on the product side, since it's H2O, you're going to have 2 different water molecules on this side. So we need to make 1 more water molecule that looks like this. So when we get down here to the bottom, we're going to have 2 water molecules, and we still have 2 hydrogens because it's H2, 2 oxygens, O2, but then we have 2 here, Now we have two waters. Okay, that doesn't mean two hydrogens only. That means two of the whole thing. So we have two water. H2O. Actually, I did that incorrectly. Fix it really quick. No big deal. So, all right. So now let's see if we're in balance again. That's what we need to figure out. If we're in balance. So hydrogens are obviously green. There we go. Okay. So now we have two waters. Excellent. So now if we look back, now we have two oxygens, two reds here on the product side, now two oxygens on the reactant side. Now we have 4 hydrogens over here, but we only have two hydrogens over here. So adding a coefficient, how on earth can we get 4 hydrogens over here? So if we add a 2 in the front, that's going to be 2 times 2, which is 4, which means we need to have another H2 molecule. So it's like that. Now if we recount the whole thing, now we have 1, 2, 3, 4 hydrogens, 1, 2, 3, 4 hydrogens, 2 oxygens here, and 2 oxygens on that side. So that's to give you a good start on balancing chemical equations.